Welcome back into the dark. Right now, as you lie still, you are moving. The Earth turns beneath you. The Sun carries the Earth around the galactic center, and the Milky Way itself flows through space at 630 kilometers every second, toward something we could not see until recently. This motion is not the universe expanding. This is us, moving towards something specific, something vast, something hidden behind our own galaxy's dust. Tonight I want to show you that you have always been a passenger in the largest current of matter that exists, flowing toward a destination gravity promises, but dark energy will never let you reach. If you'd like to leave a small light behind for others who drift through here, I'd be grateful. Now lower the lights, put on your headphones, and let yourself settle in. Tonight we're mapping the current that carries you through space at 630 kilometers every second. The motion inside every moment of stillness. The pull toward a destination hidden behind our own galaxy's dust. A journey that took until 2014 to name, only to reveal that what pulls us is itself being pulled toward something larger. Just listen, and let the distance hold you while we trace Laniakea, the immense heaven we belong to. I am the cartographer of the dark. I have been mapping these distant places for longer than I can remember, tracing the flows that carry us through a cosmos we are only beginning to understand. You are already inside the current. Right now, as you lie still, you are moving through space at more than 600 kilometers every second. Not because the universe is expanding around you, but because something is pulling you. The Earth spins beneath you. The Earth orbits the Sun. The Sun orbits the center of the Milky Way, a circuit so vast, it takes 230 million years to complete. And the Milky Way itself, along with every galaxy near it, is flowing towards something hidden in the distance. A destination we named before we could see it. A place we will spend eternity moving toward, and never reach. This is not expansion. This is motion with a direction. A current carrying everything you are across a river of gravity so wide it took us until 2014 to understand we were inside it. If you would like to drift through the rest of this journey with us, consider subscribing to Sleep Among Galaxies. We map the dark while you rest. Now lower the lights, put on your headphones. Every scale of motion nests inside a larger one. You rotate with the planet. The planet orbits the star. The star orbits the galactic core. And the galaxy flows, not randomly, not in response to the stretching of space itself. The Milky Way is being pulled, along with tens of thousands of other galaxies, toward a gravitational focal point roughly 200 million light-years away, hidden behind a veil of dust we could not see through for decades. We call that focal point the Great Attractor. But the Great Attractor is not the end of the current. It is itself being pulled toward something larger still. This motion was not obvious. For most of human history, we believed the stars were fixed. Then we realized the stars were moving. Then we realized the Milky Way was one galaxy among billions, and that those galaxies were receding from one another as space expanded. The universe, we learned, had no center, no preferred direction. Every point was equivalent. But in the 1970s, astronomers measuring the faint afterglow of the Big Bang noticed something strange. That afterglow, the cosmic microwave background, should have been perfectly uniform. A smooth glow in every direction. Instead, it was slightly warmer in one direction, slightly cooler in the opposite direction. The asymmetry was small, but it was real. And it had only one explanation. We were moving, not because space was expanding, but because our entire region of the universe was drifting through space, towards something, with enough mass to pull us. The speed of that drift is approximately 630 kilometers per second. Faster than the Earth orbits the Sun. Faster than the Sun orbits the galactic core. If you could stand outside the Milky Way and watch, you would see our galaxy and all its neighbors flowing like water toward a single basin, a gravitational low point in the fabric of space. We did not know what that basin was. We could measure the motion, but we could not see the destination. For years the pull had no name, only a direction, toward the constellations Norma and Triangulum Australe, in the southern sky, toward a region of space obscured by the Milky Way's own dust and starlight, a blind spot, a zone we could not map with visible light because our own galaxy was in the way. Then, in the late 1980s, a team of 7 astronomers conducted a systematic survey of the motion of hundreds of galaxies. They measured how galaxies were moving relative to cosmic expansion, their peculiar velocities, the deviations from the average flow, and they found a pattern, galaxy after galaxy, across millions of light-years, all drifting in the same direction, all being pulled toward the same region of sky. They named it the Great Attractor, a name for something they could not yet see. It would take decades to fill in the map. Radio waves and infrared light pass through the dust that blocks visible wavelengths. Slowly, as new instruments came online, astronomers began to peer through the zone of avoidance. They found clusters of galaxies, concentrations of mass, structures vast enough to warp space around them. The Great Attractor was not a single object, not a black hole, not a thing you could point to. It was a place, a diffuse region of space, 400 million light-years across, where matter had gathered in greater density than the surrounding void. A gravitational focal point, millions of galaxies flowing toward it, including ours. But when astronomers finally measured the mass of the Great Attractor, they found something unexpected. It was not large enough. The pull we were feeling required more mass than the Great Attractor contained. Something else was contributing to the current. Something farther away. Something larger. In 2014, a team led by an astronomer named Brent Tully published a new map. Not a map of galaxies, but a map of motion. They traced the peculiar velocities of thousands of galaxies across hundreds of millions of light-years, following the flow of matter the way you might trace a river back to its source. And they found the watershed, the boundary where galaxies stopped flowing toward one center and began flowing toward another. They named it Laniakea, immense heaven, a word chosen to honor the Polynesian navigators who crossed the Pacific by reading the stars, who understood that motion and direction were forms of belonging. Laniakea is not a structure in the traditional sense. It has no walls, no boundary you could cross. It is defined entirely by motion, by the fact that every galaxy within it across 500 million light-years of space is flowing inward toward the same gravitational center. That center is the Great Attractor. 100,000 galaxies, a total mass equal to 100 quadrillion suns, all of it drifting, over billions of years toward a focal point we could not see because our own galaxy was in the way. The Milky Way sits near the outer edge of Laniakea, not at its center. We are passengers, carried along a route we did not choose, inside a structure so large it took us until 2014 to know we were inside it. And Laniakea is not the end of the map. Beyond the Great Attractor, 650 million light-years from the Milky Way, lies the Shapley Supercluster, one of the largest concentrations of mass in the observable universe. A gathering of galaxies so immense that it pulls not just individual galaxies, but entire superclusters. The Great Attractor is moving toward Shapley. Laniakea is moving toward Shapley. The current does not stop. It continues, across distances that dwarf anything we can hold in our minds, toward a destination even farther than the one we named first. Some astronomers now believe that Shapley may be the gravitational anchor of everything in our corner of the cosmos. Others are less certain. The map keeps expanding. Every answer reveals a larger question. Every center we identify turns out to be off-center from something else. But here is the paradox. The destination recedes. The Great Attractor, the Shapley Supercluster, every gravitational focal point we are moving toward, is also moving away from us. Not because it is fleeing, because space itself is expanding, and, at the largest scales, expansion wins. Gravity pulls. Dark energy, the force we discovered in 1998 when we realized the universe's expansion was accelerating, pushes harder. The distance between us and the Great Attractor grows faster than we can cross it. We are moving toward it at 630 kilometers every second. It is receding from us faster than that. We'll never arrive. The journey has no end. Only motion, only the current, and still you are part of it. Right now. As you rest, the Milky Way flows through Laniakea. Laniakea flows toward the Great Attractor. The Great Attractor flows toward Shapley. And you, lying still in the dark, are moving with it. 630 kilometers every second. 14 times farther than the distance from the Earth to the Moon, every single second. Not because you chose to, because everything is moving. Because motion is the only constant. Because the universe does not hold still for anything, not even for sleep. I wonder where you are right now, listening in the dark. The stars overhead look different from every place on Earth. If you'd like to leave your city and local time below, I'm genuinely curious what part of the world is drifting with me tonight. In the 1970s, astronomers began to notice something unexpected in the faint afterglow of the Big Bang itself. The cosmic microwave background radiation, that ancient light left over from the moment the universe first became transparent, should have been perfectly uniform in every direction. A featureless glow, the same temperature no matter where you looked. But it was not. In one direction, the radiation was slightly warmer. In the opposite direction, slightly cooler. The asymmetry was subtle, measured in fractions of a degree, but it was unmistakable, and it had only one explanation. We were moving towards something specific. This asymmetry became known as the cosmic microwave background dipole. The dipole pattern, warm on one side and cool on the other, is the signature of motion through the universe itself. When you move toward a source of light, the wavelengths compress, and the light appears warmer. When you move away, the wavelengths stretch, and the light appears cooler. The dipole told astronomers that the Milky Way, the local group of galaxies around it, and everything in our immediate cosmic neighborhood, was flowing in a single direction, at approximately 630 kilometers per second. This was not the expansion of the universe carrying space itself outward. This was us, moving toward something we could not yet see. The cosmic microwave background fills the entire sky. It is the oldest light in the universe, released 380,000 years after the Big Bang, when the cosmos cooled enough for atoms to form and photons to travel freely. That light has been traveling for more than 13 billion years. It reaches us from every direction at once, a faint glow at microwave wavelengths, invisible to the eye but detectable by radio telescopes. It should be isotropic, the same in every direction, because the early universe was nearly perfectly smooth. But the dipole breaks that symmetry. One hemisphere of the sky is warmer by a few thousandths of a degree. The other is cooler by the same amount. The pattern is not random. It is the imprint of our motion through the radiation itself. For years, the dipole remained a mystery without a destination. The motion was real, but the cause was hidden. Astronomers knew we were moving, but they did not know what was pulling us. The cosmic microwave background is a map of the universe as it was in its infancy, not as it is now. The dipole told us we were in motion, but it could not tell us what lay at the end of that motion. To answer that question, astronomers would need to map the galaxies around us, measure their distances and velocities, and trace the flow of matter across hundreds of millions of light-years. That work began in earnest in the 1980s. A group of 7 astronomers began a systematic study of the peculiar velocities of galaxies, the way they move relative to the smooth expansion of space. Their names were Alan Dressler, Sandra Faber, David Burstein, Roger Davies, Donald Lyndon Bell, Roberto Terlovich, and Gary Wegner. Later, they would be called the 7 Samurai. They measured the distances and motions of roughly 400 elliptical galaxies, mapping the flow of matter across a volume of space larger than anything humanity had ever charted. The work was painstaking. Each galaxy required careful observation, precise measurements of brightness and internal motion, calculations to estimate its true distance. But the pattern that emerged was undeniable. The 7 Samurai used a technique called the fundamental plane relation, a way of estimating the true distances to elliptical galaxies by comparing their brightness, size, and the speed at which stars orbit inside them. With those distances in hand, they could measure how fast each galaxy was moving toward or away from us, and then subtract the motion caused by the expansion of the universe. What remained was the peculiar velocity, the galaxy's own drift through space. And when they mapped those velocities, they found something extraordinary. The galaxies were not moving randomly, they were falling, flowing, converging on a single region of sky, in the direction of the constellations Norma and Triangulum Austral, near Centaurus. In the late 1980s, they named the destination. They called it the Great Attractor. They could not yet see it. The region lay almost directly behind the plane of the Milky Way, hidden by the dust and gas of our own galaxy. But the motion was undeniable. Hundreds of galaxies, scattered across a volume of space larger than anything humanity had ever mapped, were all being pulled in the same direction. The Milky Way was one of them. The Virgo Supercluster, the vast collection of galaxies that includes our own, was another. We were not observers of this flow, we were inside it. The discovery of the Great Attractor did not come from seeing the thing itself. It came from watching the way everything around it moved. Imagine standing in a river with your eyes closed. You cannot see the current, but you can feel the water pulling you downstream. You can watch leaves and branches drift past, all moving in the same direction. The 7 Samurai had found the current. They had traced it back to its source. But the source itself remained invisible, hidden behind the densest part of the Milky Way's disk, in a region astronomers had already begun to call the Zone of Avoidance. The cosmic microwave background dipole had revealed the motion. The 7 Samurai had given it a name and a direction. But the question remained: what was pulling us? What lay at the center of the flow? For decades, the answer was obscured by our own galaxy. The Milky Way's dust and stars blocked nearly a fifth of the extragalactic sky, and the Great Attractor lay squarely in the middle of that blind spot. Every telescope pointed in that direction saw only the foreground, the clutter of our own cosmic neighborhood. The destination remained dark. It was not until the development of radio and infrared astronomy, wavelengths that pass through dust as if it were glass, that astronomers could begin to map what lay behind the veil. Radio waves are long, far longer than the particles of dust that block visible light. Infrared light penetrates the haze. Slowly, galaxy by galaxy, the structure of the Great Attractor began to emerge. It was not a single object. It was a diffuse concentration of matter, a gravitational focal point, roughly 400 million light-years across, located between 150 and 250 million light-years from the Milky Way. Millions of galaxies were flowing toward it, including our own. But even as the map filled in, the story grew more complex. In 2005, an X-ray survey conducted by the CIZA project revised the mass of the Great Attractor downward to roughly 1/10 of the original estimate. The pull was real, but the Great Attractor was not massive enough to account for all of it. When astronomers looked further, they found that the Great Attractor itself was moving. It was being pulled towards something larger, something far more massive, lying 650 million light-years away, the Shapley Supercluster. The pull did not stop at the Great Attractor, it continued beyond it. The cosmic microwave background dipole had been the first clue, a faint asymmetry in the oldest light in the universe. A signal written into the sky long before the Earth existed, long before the Sun ignited, long before the Milky Way had taken its present shape. The Seven Samurai had traced that asymmetry to a gravitational focal point and given it a name. But the destination kept receding. Every time astronomers thought they had found the center of the flow, they discovered that the center itself was part of a larger current. The map kept expanding. The motion remained the same. The dipole in the cosmic microwave background is still there, still visible, still pointing in the same direction. It has not changed. It will not change. It is the signature of our motion through the universe, written into the oldest light that exists. And every measurement we make, every galaxy we map, every refinement of the flow, confirms what the dipole first revealed. We are not standing still. We have never been standing still. We are carried right now, across distances no single human lifetime can comprehend, toward a destination that recedes as we approach it. The current is older than the Earth. The motion is older than the Sun, and the dipole, faint and persistent, remains the only compass we have ever had. The Great Attractor is not a thing. It is a place, a gravitational focal point toward which millions of galaxies are flowing, including our own. When the astronomers in the late 1980s finally gave the pull a name, they still could not see what they were naming. They had traced the motion of hundreds of galaxies, mapped the direction of the flow, calculated the velocity and the distance. They knew something massive was drawing the Milky Way and everything around it toward a single region of sky. But the region itself remained invisible, hidden behind the plane of our own galaxy, obscured by dust and gas and the light of 100 billion stars between us and the answer. So they named the destination before they could see it. They called it the Great Attractor, a name for something that existed only as an effect, a pull, a direction written into the motion of galaxies across a span of space so vast that light takes hundreds of millions of years to cross it. The Great Attractor lies roughly 150 to 250 million light-years from the Milky Way, in the direction of the constellations Norma and Triangulum Australe near Centaurus. It is not a black hole, it is not a singularity, it is not a single object at all. It is a diffuse concentration of matter, a gravitational basin approximately 400 million light-years in size, where tens of thousands of galaxies have gathered over billions of years, their combined mass bending space itself, creating a slope down which everything nearby slides. The Milky Way is sliding toward it. So is the local group, the small cluster of galaxies we belong to. So is the Virgo Supercluster, the larger structure that contains the local group. So is the Hydra Centaurus Supercluster, a neighboring concentration of thousands of galaxies, all of them moving in the same direction, at velocities measured in hundreds of kilometers per second. Some of the closer galaxies are falling toward the Great Attractor, at speeds that approach thousands of kilometers per second. The flow is not chaotic, it is coherent. Millions of galaxies, across hundreds of millions of light-years, all responding to the same gravitational call. For decades, astronomers could only infer its existence. They could measure the motion, trace the flow, calculate where the center should be, but they could not observe it directly. The Great Attractor sits almost exactly behind the plane of the Milky Way, in a region called the Zone of Avoidance. Our own galaxy was hiding the answer from us. The gas and dust and starlight of the Milky Way's disk blocks nearly a fifth of the extragalactic sky at visible wavelengths. The very thing we wanted to see was located in the one direction we could not look. So for years, the Great Attractor remained a name without a face, a pull without a source, a destination marked on maps by inference alone. Then, slowly, the instruments changed. Radio waves pass through dust that blocks visible light. So does infrared. As X-ray and infrared astronomy became more powerful in the 1990s and 2000s, astronomers began to peer through the veil. They mapped the zone of avoidance one wavelength at a time, filling in the blank regions, revealing what had always been there but invisible. What they found was not empty space. It was full. Clusters of galaxies, each containing hundreds or thousands of individual galaxies, all gathered in the region where the flow converged. The Norma Cluster, a massive concentration of galaxies at the heart of the Great Attractor region, became one of the first direct confirmations of what the gravitational focal point actually contained. Not a void, not a singularity, just mass. Galaxies and gas and dark matter, gathered together in quantities large enough to pull everything around them inward. The Great Attractor was real. It had structure. It had a location. It could be mapped. But the map was not yet complete. In 2005, an X-ray survey revised the mass estimate of the Great Attractor downward. The gravitational focal point was not as massive as the original calculations had suggested. It was only about 1/10 the mass astronomers had once believed. That should have been a disappointment, a reduction, a correction that made the Great Attractor smaller, less significant. Instead, it revealed something larger. When astronomers recalculated the motion of the Milky Way with the new mass estimate, they realized the Great Attractor alone could not account for the full velocity, the 630 kilometers per second. The coherent flow across such a vast region of space. If the Great Attractor was less massive than they thought, then something else had to be pulling. Something farther away. Something even larger. They found it. Behind the Great Attractor, deeper in the same direction, another structure waited. The Shapley Supercluster. A concentration of galaxies centered roughly 650 million light-years from the Milky Way, in the constellation Centaurus, one of the largest gravitationally interacting structures in the observable universe. A gathering of mass so immense that its pull reaches across 500 million light-years of space. The Great Attractor was not the whole answer. It was only part of the story. The Great Attractor itself was being pulled. The flow did not stop at the gravitational focal point the astronomers had named. It continued beyond it. The pull behind the pull. A deeper current, drawing everything in our region of the universe toward Shapley. Studies suggest that more than half of the Milky Way's motion may be driven not by the Great Attractor, but by the Shapley Supercluster. The destination we thought we were moving toward was itself only a waypoint. The journey was longer than we knew, and the structure we belonged to was larger than we had imagined. In 2014, astronomer Brent Tully of the University of Hawaii and his colleagues published a map that redefined our address in the universe. They had traced the peculiar velocities of galaxies across hundreds of millions of light-years, measuring not just how fast galaxies were moving away from us due to the expansion of space, but how they were moving relative to that expansion. The motion that was not expansion. The motion that was flow. They found the watershed, the boundary where galaxies on one side flowed in one direction and galaxies on the other side flowed in another. The dividing line that separated one basin of gravitational infall from the next, and they mapped the full volume of space where all galaxies were flowing toward the same center. They named it Laniakea, from the Hawaiian words for heaven and spacious, immense heaven. A name chosen to honor the Polynesian navigators who crossed the Pacific by reading the stars, who understood that knowing where you are means knowing which current carries you. Laniakea is approximately 500 million light-years across. It contains roughly 100,000 large galaxies, with a combined mass equal to 100 quadrillion suns. It is not defined by boundaries in space. It is defined by motion, by flow, by the direction everything inside it is moving. Think of it like a watershed on Earth. Rain on one side of a mountain flows into one river. Rain on the other side flows into another. Laniakea is our cosmic watershed. Everything in it flows toward the same center. That center is the Great Attractor. The Milky Way sits near the outer edge of Laniakea, not at its center. We are in the outskirts. Passengers at the edge of a structure so large, it took us until 2014 to know we were inside it. A structure 5,000 Milky Ways wide. A current that has been flowing since before the Earth existed. And the current itself is being pulled toward Shapley. Some astronomers now believe that the Shapley Supercluster may be the gravitational anchor of everything in our corner of the cosmos, that Laniakea and several other nearby superclusters may all be moving toward it, making Shapley the center of the entire local universe. Others are less certain. The map keeps expanding, the instruments improve, the distances grow. But one thing is clear, the Great Attractor was never the final destination. It was only a name we gave to the pull before we understood how far the pull extended. A marker on a map that was still being drawn. A place we are moving toward, even as we discover that the place itself is moving towards something else. And we will never arrive. For decades, astronomers could measure the pull but could not see what was pulling. They had traced the flow of galaxies across millions of light-years. They had named the destination. They had calculated the speed. But the Great Attractor itself remained invisible, hidden behind a veil they could not lift. The problem was not distance, it was not the limits of their instruments, the problem was location. The Great Attractor lies almost directly behind the plane of the Milky Way in a region astronomers call the Zone of Avoidance. Our own galaxy was hiding the answer from us. The Milky Way is a disk of stars, gas and dust, stretching 100,000 light-years across. When you look outward from Earth, most directions offer a clear view into deep space. But when you look toward the galactic plane, the view is obscured. The dust and gas of the Milky Way's disk block nearly a fifth of the extragalactic sky at visible wavelengths. Light from distant galaxies cannot reach us through that curtain. For much of the 20th century, astronomers could map the universe in every direction except the one that mattered most. The Great Attractor lies in the constellation Norma, near Triangulum Australe, deep inside the Zone of Avoidance. The very thing pulling the Milky Way through space was concealed by the Milky Way itself. Imagine trying to map a coastline while standing on an island surrounded by fog. You can see the ocean in most directions, you can measure the currents, you can feel the pull of the tide. But in one direction the fog is so thick that you cannot see the shore at all. You know something is there, the water is flowing toward it. But you cannot confirm it. You cannot measure it. You cannot even be certain it exists. For years, the Great Attractor was a gravitational ghost. Astronomers could detect its influence on the motion of galaxies, but they could not observe the structure itself. The Zone of Avoidance was a blind spot at the center of the most important question in large-scale cosmology. The solution came not from building larger telescopes but from looking at different wavelengths. Visible light cannot pass through the dust and gas of the Milky Way's disk. But radio waves can. Infrared light can. These wavelengths are transparent to the material that blocks our view. Slowly, as X-ray and infrared astronomy became more powerful in the 1990s and 2000s, astronomers could finally begin mapping what lay behind the veil. The map was filled in one wavelength at a time. In the 1990s, the ROSAT satellite conducted an all-sky X-ray survey. It revealed a massive cluster of galaxies at the center of the Great Attractor region. The cluster is called the Norma cluster, catalogued as Abell 3627. It is one of the most massive galaxy clusters in the nearby universe, and it sits almost exactly where the gravitational focal point was predicted to be. For the first time, astronomers could see what was there. Not a black hole, not a singularity, not a single object at all. The Great Attractor is a diffuse concentration of matter, a gravitational basin where millions of galaxies are flowing together. The Norma cluster is at its heart, but the structure extends far beyond it, a web of galaxies and dark matter spanning hundreds of millions of light-years. The Zone of Avoidance had kept it hidden, but the veil was lifting. Infrared surveys followed. Radio observations mapped the distribution of hydrogen gas in galaxies behind the Milky Way's plane. Each new wavelength added detail to the map. Each observation confirmed what the peculiar velocities had suggested. The Great Attractor was real, it was massive, and it was exactly where the flow had pointed. But the map also revealed something unexpected. When astronomers finally measured the mass of the Great Attractor directly, using X-ray observations and galaxy counts, they found it was smaller than they had expected. The gravitational pull required to explain the Milky Way's motion was stronger than the mass of the Great Attractor alone could account for. The numbers did not match. The Great Attractor was not the whole answer. Behind it, something far larger was waiting. The Zone of Avoidance had hidden more than one structure. It had hidden the fact that the Great Attractor is itself being pulled. The flow does not stop at the gravitational focal point. It continues beyond it, toward a region of space even more distant, even more massive. That region is called the Shapley Supercluster, and it lies 650 million light-years from the Milky Way, deep in the constellation Centaurus. Shapley is one of the largest concentrations of mass in the observable universe. It contains thousands of galaxies, bound together by gravity into a structure so vast that it dominates the motion of everything around it. Studies suggest that more than half of the Milky Way's motion may be driven not by the Great Attractor, but by Shapley. The pull we feel is the combined influence of two structures, one behind the other, both hidden for decades by the dust and gas of our own galaxy. The Zone of Avoidance was not just a technical obstacle, it was a reminder that the universe does not arrange itself for our convenience. The most important structures in our cosmic neighborhood happen to lie in the one direction we could not easily observe. The answer was always there. We simply could not see it. For much of the 20th century, astronomers knew they were being pulled toward something. They could measure the speed, they could trace the direction. But they could not confirm what lay at the end of the flow. They were navigating by instruments alone, mapping a destination they could not observe. It was only when they learned to see through the veil, to look at wavelengths the dust could not block, that the map began to take shape. The Great Attractor emerged from the Zone of Avoidance, not as a single object, but as a gravitational landscape. And beyond it, Shapley appeared, a larger structure pulling on the Great Attractor itself. The blind spot is still there. Nearly a fifth of the sky remains obscured at visible wavelengths. But the map is no longer blank. Radio telescopes and infrared observatories have filled in the missing regions. The zone of avoidance is still a zone of difficulty, but it is no longer a zone of ignorance. We can now see, in wavelengths our eyes were never built to perceive, the structures that have been pulling the Milky Way for billions of years. The veil has not been removed. It has been seen through. And what lies behind it is not a destination. It is a current, a flow of galaxies moving together across distances so vast that light takes hundreds of millions of years to cross them. The Great Attractor is the focal point of that current. Shapley is the deeper pull beneath it. And the Milky Way, along with everything in the local group, is carried along, moving at 630 kilometers every second, toward a place we could not see until we learned to look in the right way. The zone of avoidance taught astronomers a lesson about scale and patience. The universe does not reveal itself all at once. Sometimes the answer is hidden not by distance but by proximity. Sometimes the thing you are looking for is concealed by the thing you are standing on. For decades, the Milky Way's own dust and gas blocked the view. Now, slowly, the map is being drawn. The structures behind the veil are emerging. And the flow that carries us, the current that has been moving the Milky Way since long before the Earth existed, is finally visible. Not in the light our eyes can see, but in the wavelengths that pass through the dust, in the radio signals that travel unimpeded across the galactic plane, in the infrared glow of distant galaxies, faint but unmistakable, shining through the veil. The Great Attractor is no longer hidden. The zone of avoidance is no longer a mystery. And the map, though still incomplete, is no longer blank. In September of 2014, a team of astronomers led by Brent Tully at the University of Hawaii published a paper that redrew the map of everything we thought we knew about our place in the cosmos. They had traced the motion of galaxies across hundreds of millions of light-years, following the peculiar velocities that reveal where matter is actually flowing beneath the smooth expansion of space. What they found was a structure so vast that the Milky Way, the local group, the Virgo Supercluster, and tens of thousands of other galaxies were all part of a single gravitational watershed, all flowing toward the same center. They gave this structure a name, Laniakea, immense heaven, a name chosen to honor the Polynesian navigators who crossed the Pacific by reading the stars, who understood that to know where you are, you must first understand the currents that carry you. Laniakea is not held together by walls or boundaries. It is defined purely by motion. Think of it like a watershed on Earth. Rain that falls on one side of a mountain flows into one river. Rain on the other side flows into another. The ridge between them is invisible, but the water knows which way to go. Laniakea is our cosmic watershed. Everything inside it, every galaxy across 500 million light-years of space, is flowing inward toward the same gravitational focal point. That focal point is the Great Attractor. 500 million light-years. The Milky Way is 100,000 light-years from edge to edge. Light-years 5,000 Milky Ways wide. Within that volume, 100,000 large galaxies drift through the dark, their combined mass equal to 100 quadrillion suns, all of them moving, all of them falling along invisible lines of gravity that converge on a single region of sky hidden behind the dust and stars of our own galactic disk. We live near the outer edge of this structure, not at its center. We are in the outskirts. Passengers at the rim of something so large it took us until 2014 to know we were inside it. For decades, astronomers had known that the Milky Way was moving toward the Great Attractor. They had measured the velocity, traced the direction, named the destination, but they did not know what larger structure that motion belonged to. They could see the flow but not the basin. They could measure the pull but not the boundary. Tully and his colleagues mapped it by following the flow. They measured how galaxies move relative to the expansion of the universe, how some drift toward us and others away, how the net motion reveals the gravitational landscape beneath. Slowly, galaxy by galaxy, the watershed took shape. The boundary emerged not as a line, but as a change in direction, the place where galaxies on one side flow toward the Great Attractor, and galaxies on the other side flow toward something else entirely. It was cartography by motion, a map drawn not in space but in velocity. The work took years. Tully's team gathered data from thousands of galaxies, measuring redshifts and distances, calculating how each one moved through space after accounting for the universe's expansion. The cosmic microwave background gave them a reference frame. The faint light left over from the Big Bang was not perfectly even. It was warmer in one direction, cooler in the opposite. That asymmetry had only one explanation. We were moving towards something. The dipole in the microwave background was the signature of our motion, the proof that the Milky Way and everything around it was being pulled through space at 630 kilometers every second. But knowing the speed and direction was not enough. The question was how far the current extended. Where did it begin? Where did it end? Tully's method answered that. By mapping peculiar velocities across a volume of space 500 million light-years wide, his team could trace the lines of infall, the paths that galaxies follow as they fall toward regions of higher density. Those lines converged, they all pointed toward the same place. The Great Attractor sat at the center, not as a single object, but as a gravitational focal point, a place where the flow of millions of galaxies met. Laniakea is not a cluster in the traditional sense. It is not a single gravitationally bound object like the local group or the Virgo cluster. It is too large for that. Gravity at this scale cannot hold against the expansion of space. Laniakea is a temporary structure, a pattern in the flow that will not last forever. The galaxies inside it are moving toward a common center, but they will never all arrive. The universe is expanding, and at distances this vast, expansion wins. Dark energy, the force with no name we can fully explain, pushes space apart faster than gravity can pull it together. Laniakea is not a permanent address, it is a current. The name itself carries weight. Laniakea, immense heaven. The Hawaiian language has no word for space in the modern astronomical sense, but it has words for vastness, for the open sky, for distances that cannot be crossed. Tully chose the name because the work was done in Hawaii, because the data came from telescopes on Mauna Kea, because the mapping of cosmic flows is an act of navigation as ancient as any voyage across open water. The Polynesians who settled the Pacific did not have maps. They had an understanding of currents, of winds, of the way stars move across the sky. They knew that to find an island you do not aim for where it is, you aim for where the current will carry you. Laniakea is the current we are inside. But the map did not stop there. When Tully and his team published their results, they also confirmed something that earlier observations had hinted at. The Great Attractor is not the final destination. The Great Attractor is itself being pulled toward something larger. Beyond it, 650 million light-years from the Milky Way, lies the Shapley Supercluster, one of the most massive concentrations of matter in the observable universe. Studies suggest that more than half of our motion may be driven not by the Great Attractor but by Shapley, a structure so dense and so distant that its gravity reaches across hundreds of millions of light-years. The pull does not stop. It continues, rung after rung, scale after scale, until the expansion of the universe itself becomes the dominant force. Laniakea contains the Great Attractor, but it does not contain Shapley. The watershed has an edge. Beyond that edge, galaxies flow in a different direction, toward a different center. Some astronomers now believe that Shapley may be the gravitational anchor of everything in our corner of the cosmos, that Laniakea and several other nearby superclusters may all be falling toward it. Others are less certain. The map keeps expanding. We are not at the center of Laniakea. We are not at the center of anything. The Milky Way drifts near the outer edge of a structure that stretches halfway across 1 billion light-years, flowing along with 100,000 other galaxies toward a gravitational focal point we could not see for decades, because our own galaxy was in the way. The Zone of Avoidance, the band of sky where the Milky Way's dust and stars block our view, hid the Great Attractor from us until we learned to look in wavelengths that dust cannot stop. Radio waves, infrared light, X-rays. Slowly the map was filled in, one wavelength at a time. Laniakea is the answer to a question we did not know how to ask, until we had the tools to see motion at cosmological scales. For most of human history, the universe appeared still. The stars were fixed. It was only in the 20th century that we learned the stars are moving, the galaxies are moving, and the motion is not random. It follows structure. It follows gravity. The cosmic microwave background is warmer in one direction and cooler in the opposite direction, because we are moving through it at 630 kilometers every second. That motion is not the expansion of the universe. It is us, the Milky Way, the local group, the whole of Laniakea, flowing through space toward a destination that recedes as we approach. We are moving toward it. It is moving away from us. Gravity pulls. Dark energy pushes harder. The race was decided long ago. We will never arrive. The Great Attractor is already receding, carried away by the expansion of space faster than our motion can close the distance. In a universe governed by dark energy, every structure larger than a galaxy cluster is temporary. Laniakea will not hold. The galaxies inside it will drift apart, each one carried by the expanding fabric of space into isolation, into a future where the flow stops and every galaxy becomes an island. But that future is billions of years away. Tonight, Laniakea still exists. The flow still carries us. Across 500 million light-years, 100,000 galaxies move in the same direction, falling along the same invisible lines, pulled by the same vast and patient gravity. We are part of that flow. The Milky Way, the Sun, the Earth, you, everything you have ever known, is inside the current. You are being carried, right now, across a distance no human mind can fully hold, toward a place you will never reach, inside a structure so large it took us until 2014 to know we were inside it. Laniakea, immense heaven, not a point, but a motion, not a place, but a direction, not a destination, but a belonging. Beyond the Great Attractor, deeper still into the direction we call south, past the dust and gas that hid the first answer from us, there is something else. Something larger. The Great Attractor is not the final destination. The Great Attractor is itself being pulled towards something that took decades longer to understand. Something so massive that when astronomers finally measured it, they had to revise every assumption about what was driving our motion through the cosmos. Its name is the Shapley Supercluster, and it lies 650 million light-years from the Milky Way, in the constellation Centaurus, far beyond the gravitational focal point we spent the late 1980s trying to name. 650 million light-years. The number alone tells you nothing. But consider this. Laniakea, the immense heaven that contains our galaxy and 100,000 others, stretches 500 million light-years from edge to edge. Shapley lies beyond that, beyond the outer boundary of the watershed we belong to. It sits in a region of space so distant that the light reaching us tonight left those galaxies, when the first forests were spreading across the continents, when the ancestors of every living thing on Earth were still learning to breathe air. The Great Attractor is moving. Not just pulling us toward it, but flowing in its own current, carried by a tide even larger than the one that carries us. When the X-ray surveys of the early 2000s finally pierced the zone of avoidance and measured the mass of the structures hidden there, the numbers did not add up. The Great Attractor was not massive enough to account for the full velocity of our motion. The 630 kilometers per second that shows up as a warm spot in the cosmic microwave background, the flow that the Seven Samurai traced by measuring the distances to 400 elliptical galaxies, something else had to be pulling. Something farther out, something we had not yet mapped, something that dwarfed even the 100,000 galaxy structure we would later call Laniakea. The Shapley Supercluster is one of the largest gravitationally interacting structures in the observable universe. Not the largest, but vast enough that when you try to picture it, the mind falters. It is not a single object. It is a concentration, a gathering of galaxy clusters so dense and so massive that its gravity reaches across hundreds of millions of light-years and bends the motion of everything in its direction. The Great Attractor is caught in that pull. Laniakea is caught in that pull. The Normocluster, the dense knot of galaxies that X-ray telescopes finally revealed at the heart of the Great Attractor region, is caught in that pull. We are caught in that pull, even though the structure doing the pulling lies so far away that the light we see from it tonight left its galaxies long before the first animals walked on land. Studies suggest that more than half of our motion may be driven by Shapley, not the Great Attractor. The velocity that defines us. The flow that shows up in every measurement of our peculiar motion. The current that took until 2014 to map as a single coherent watershed. Most of that motion may not be aimed at the Great Attractor at all. It may be aimed past it, toward the far more massive structure waiting beyond. The one we could not see until we had the instruments to look through the dust, and the mathematics to trace the flow across distances so large that no human metaphor holds them comfortably. Shapley is not a place you can point to and say, there, that galaxy, that cluster, that single bright dot in the southern sky. It is a region, a convergence. A place where tens of thousands of galaxies have gathered over billions of years, their combined mass so great that space itself bends toward them, and everything within 650 million light-years feels the pull. The Great Attractor is one node in that flow. Laniakea is one watershed. And Shapley, some astronomers now believe, may be the gravitational anchor of everything in our corner of the cosmos. Others are less certain. The data is still being gathered. The map keeps expanding. Every time we think we have traced the full extent of the current, we find another layer, another structure, another pull behind the pull. The universe does not reveal its architecture all at once. It gives up its secrets one wavelength at a time, one survey at a time, one decade of patient observation at a time. First we saw the motion in the cosmic microwave background. Then we traced it to the Great Attractor. Then we looked through the zone of avoidance with X-rays and infrared light, and found that the Great Attractor was smaller than we thought. Then we mapped Laniakea, and understood that we lived inside a structure 500 million light-years across, defined not by boundaries but by flow. And then, looking farther still, we found Shapley. The pull behind the pull. The answer behind the answer. The place the Great Attractor is falling toward, just as we are falling toward the Great Attractor. The Great Attractor is not the end of the story, it is a chapter. A waypoint. A place we are moving toward, yes, but also a place that is itself moving, carried by the same forces that carry us, subject to the same vast gravitational choreography that has been unfolding since the first galaxies began to fall toward one another in the cooling aftermath of the Big Bang. Motion inside motion inside motion. The Earth spins. The Earth orbits the Sun. The Sun orbits the galactic center. The Milky Way flows toward the Great Attractor. The Great Attractor flows toward Shapley. And Shapley itself, 650 million light-years away, is pulling on structures so distant that we have only begun to map them. You are inside Laniakea. Laniakea is flowing toward the Great Attractor. The Great Attractor is flowing toward Shapley. The motion does not stop. The pull does not stop. Every scale of structure is nested inside a larger one. Every current flows into a deeper current. Every map we draw reveals the need for a larger map. And all of it, the Milky Way, the local group, the 100,000 galaxies of Laniakea, the millions of galaxies flowing in the same direction across the southern sky. All of it is moving toward a place 650 million light-years away, a place so massive that its gravity has been shaping our motion since before the solar system formed. Shapley is not something you will ever see with your own eyes. Its galaxies are too faint, too far, too scattered across a region of sky that requires instruments we did not have until this century. But you are moving toward it right now. You have been moving toward it since before you were born. The Earth, the Sun, the Milky Way, the local group, Laniakea, all of it flowing in the same direction, across a distance so large that light itself takes 650 million years to cross it, toward a gravitational center that has been pulling on us since long before there were eyes to look up and wonder why the stars were not standing still. And yet, even as we move toward it, even as the Great Attractor moves toward it, even as the entire flow of galaxies in our region of the universe bends in its direction, we will never arrive, because the universe is expanding. Because dark energy, the force with no name we can fully explain, the force that won 2 independent teams of astronomers the Nobel Prize in 2011 when they confirmed the expansion was accelerating, is pushing space apart faster than gravity can pull it together. At the scale of superclusters, at the scale of Laniakea, at the scale of the 650 million light-year gulf between us and Shapley, expansion wins. The distance grows. The destination recedes. We are moving toward it. It is moving away from us. Gravity pulls. Dark energy pushes harder. The current flows, but the basin is retreating, and no matter how fast we fall, we will never reach the place we are falling toward. The pull behind the pull is real. The motion is real. The structure is real. But the arrival is not. We are passengers in a current that has no shore, travelers on a journey that has no end, carried across a structure so vast that it took us until 2014 to know we were inside it, toward a destination we mapped only after we understood we would never reach it. Shapley is there, 650 million light-years south, pulling, waiting, receding. The Great Attractor is there, closer, brighter, but also moving, also caught in the same impossible race between gravity and expansion. And we are here, at the outer edge of Laniakea, one galaxy among 100,000, flowing in a current that began before the solar system formed, that will continue long after the sun goes dark, that carries us not toward a place we will ever stand, but toward a place that defines where we are, by defining where we are going. The pull behind the pull, the structure behind the structure, the map that required a map. You do not need to hold all of it in your mind. You do not need to picture 650 million light-years. You only need to know that the motion is there, that the flow is real, that the universe is not still, and that you are part of the current, right now, tonight, across a distance no single human life can comprehend, toward a destination that recedes even as we approach it. You are being carried. We are moving towards something we will never reach. The Laniakea Supercluster, this immense heaven that holds 100,000 galaxies in a single watershed of motion, is not a permanent address. It is not bound together the way a galaxy is bound. or the way a cluster of galaxies holds itself in gravitational embrace. Laniakea is too large, too diffuse, too stretched across 500 million light-years of space to resist what is happening to it. The universe is expanding. And at this scale, expansion wins. In 1998, two independent teams of astronomers observing distant supernovae discovered something no one expected. The universe was not simply expanding, it was accelerating. The expansion was speeding up, driven by a force with no name we can explain, no mechanism we understand. They called it dark energy. The discovery earned a Nobel Prize in 2011. The force itself remains a mystery, but its effect is clear. Dark energy constitutes roughly 70% of everything that exists in the universe. It is the dominant player, and it pushes outward relentlessly against the pull of gravity. At small scales, gravity holds. A galaxy does not dissolve. A cluster of galaxies remains bound, held together by the combined mass of hundreds or thousands of galaxies pulling on one another. These structures are gravitationally bound. They will endure. But Laniakea is not small. It is a structure so vast that the fabric of space itself stretches faster than gravity can pull it together. Dark energy is tearing Laniakea apart, slowly, inexorably, across timescales longer than the age of the Earth. The supercluster is not a permanent structure. It is a temporary current in the flow. And so we are moving toward the Great Attractor. The Great Attractor is moving away from us, not because it is fleeing, but because the space between us is expanding faster than our motion can close the gap. Gravity pulls. Dark energy pushes harder. The destination recedes. We will never arrive. This is not a failure of motion. The Milky Way is flowing at 630 kilometers every second toward the gravitational focal point that lies hidden behind the plane of our own galaxy. That motion is real. It has been constant for billions of years. The entire local group moves with us, carried by the same current. But the Great Attractor and the Shapley Supercluster beyond it exist in a universe that is stretching. The distance between us and them grows even as we move toward them. We are running a race in which the finish line retreats faster than we can run. The expansion of space is not something we move through, it is the stretching of distance itself. And at cosmological scales, across hundreds of millions of light-years, that stretching overpowers the pull of gravity. The Great Attractor is already beyond our reach. Not because it is too far, but because the universe will not allow us to close the distance. In a cosmos governed by dark energy, the larger structures do not converge. They drift apart. Laniakea is dissolving, grain by grain, galaxy by galaxy, across timescales so long that no human civilization will ever witness the change. But the mathematics are clear. We are passengers in a current that flows toward a destination we cannot arrive at. This is the paradox at the heart of the cosmic flow. Motion without arrival, a pull without resolution. The Great Attractor is not waiting for us. It is receding into a future the universe will not permit. The gravitational focal point that defines Laniakea, the place toward which 100,000 galaxies are flowing, lies approximately 150 to 250 million light-years away in the direction of the constellations Norma and Triangulum Australe. But that distance is not fixed, it grows. Every second the space between us and it expands by more distance than our motion can cross, and yet the motion continues. The Milky Way does not slow, the local group does not halt. Across Laniakea, 100,000 galaxies continue to flow in the same direction, pulled by the same gravitational gradient, moving through space that expands beneath them. The current is real, the destination is not. Dark energy was confirmed less than 3 decades ago. Before that, Cosmologists assumed the universe's expansion was slowing, pulled back by the gravity of all the matter it contained. The discovery that expansion was accelerating overturned that assumption. It revealed a universe in which the largest structures are temporary, a universe in which motion does not guarantee arrival. Laniakea will not hold. Over billions of years, the galaxies at its edges will drift beyond the gravitational watershed that defines it. The flow will weaken, the structure will dissolve. What we mapped in 2014, what we named immense heaven, is not eternal. It is a pattern in the current, a coherence that will fade as the universe expands. The boundaries of Laniakea are defined by motion, not by walls. They are the places where galaxies stop flowing toward the Great Attractor and begin flowing toward other gravitational centers. Those boundaries are already shifting. But tonight, it is still here, and we are still inside it. The race between dark energy and gravity is not a battle, it is a condition. Gravity shaped the universe in its early moments, pulling matter together into galaxies, clusters, superclusters. Dark energy shapes the universe now, pushing the largest structures apart. Both forces are active, both are real. But at the scale of Laniakea, at the scale of the Great Attractor and Shapley beyond it, dark energy is stronger. We will never reach the Great Attractor. We will never stand at the gravitational focal point and say, "Here, this is the place." The universe will not permit it. The expansion is too fast. The distance too vast. Even if we could travel at the speed of light, we would not close the gap. The space between us and the Great Attractor is expanding faster than light can cross it. And so the Milky Way flows, and will continue to flow, toward a destination that recedes. Not because the pull has weakened, but because the space between us and it is growing faster than we can cross it. Motion without resolution. A current without a shore. This is not a tragedy. It is simply the architecture of a universe governed by dark energy. The largest structures are not permanent. The deepest currents do not lead to rest. We are moving, and we will continue to move, through a cosmos that expands around us. The motion itself is the only certainty. The arrival was never promised. The Laniakea Supercluster is 500 million light-years across. Inside it, 100,000 galaxies flow in the same direction. The Milky Way is one of them. A single galaxy in a current so vast it took until 2014 to map. And that current is flowing toward a place it will never reach. Gravity pulls us forward. Dark energy pulls the destination away. The gap widens. The motion continues. The Great Attractor, that diffuse concentration of matter 400 million light-years in size, exerts its pull across the entire supercluster. Millions of galaxies respond. But the response is not enough. The pull is real, but the expansion is stronger. We are passengers in the largest structure we belong to, moving through a universe that will not let us arrive. The Great Attractor lies ahead, hidden behind the Zone of Avoidance, pulling millions of galaxies toward it with a force we can measure but not overcome. And beyond it, the Shapley Supercluster, centered 650 million light-years away, pulls harder still. Some astronomers now believe that more than half of our motion may be driven by Shapley, not the Great Attractor, the pull behind the pull. But it does not matter which force is stronger. Both destinations recede. Both lie beyond the horizon dark energy has drawn across the universe. The race is already decided. Not because we are too slow, but because the rules of the universe favor expansion over convergence. At this scale, dark energy wins. The mathematics prove it. The supernovae, those distant exploding stars that first revealed the acceleration, are still out there, still receding, still carrying the evidence of a universe that will not hold still. And yet the motion is beautiful. The Milky Way flows at 630 kilometers every second. carried by a gravitational current that has been flowing since before the Sun existed. We are not fighting the expansion, we are simply moving through it, part of a structure so large it dwarfs comprehension, flowing toward a destination we will never reach. This is the condition of the cosmos. Motion is real, arrival is not guaranteed. The Great Attractor recedes, Laniakea dissolves, the universe expands. And we flow, inside the current, toward a place that exists but will never be ours. The expansion will not stop, the motion will not cease. And the destination will continue to recede, forever just beyond the edge of what we can reach. No matter how fast we move, or how long we travel, we are moving. The universe is expanding. And the gap between motion and arrival grows wider with every second that passes. We are not at the center of anything. The Milky Way sits in the outer regions of Laniakea, far from the gravitational focal point toward which everything flows. 500 million light-years of structure surround us, a watershed of galaxies all moving in the same direction, and we are passengers near the edge, carried by a current that has been flowing since before the Earth existed, since before the Sun ignited, since before the first generation of stars had finished forging the elements that would one day become planets and oceans, and the listening mind that tries to comprehend the scale of its own motion. The scale is difficult to hold in your mind all at once. The Milky Way stretches 100,000 light-years from edge to edge, a spiral of hundreds of billions of stars, vast beyond the reach of any journey we could imagine, and yet Laniakea is 5,000 Milky Ways wide. Within that immense volume, 100,000 galaxies are all drifting toward the same destination, pulled by the same gravitational tide, their motion synchronized across distances that light itself takes 500 million years to cross. The Great Attractor is the name we gave to that destination, hidden behind the dust of our own galaxy for decades, until infrared light and radio waves could pass through the zone of avoidance and reveal what lay beyond. A diffuse concentration of matter roughly 150 to 250 million light-years away, not a black hole, not a singularity, not a thing at all, but a place, a gravitational focal point where millions of galaxies are converging, including our own. And yet the Great Attractor is not the final answer, it is itself being pulled toward something larger. The Shapley Supercluster waits 650 million light-years away, one of the largest gravitationally interacting structures in the observable universe. A concentration of mass so vast that it draws not only the Milky Way, but the Great Attractor itself toward it. The pull does not stop. The current continues beyond every boundary we have mapped. Some astronomers now believe that Shapley may be the gravitational anchor of everything in our corner of the cosmos. Others are less certain. The map keeps expanding, and with each new survey, each new wavelength of light that pierces the dust, the structure grows more intricate, the flow more layered, the destination more distant than we thought. You are inside this structure right now. You have always been inside it. The motion that carries the Milky Way at 630 kilometers per second is not something that happens to distant galaxies in photographs. It is the motion of your own position in space, the drift of the ground beneath your feet, the flow of the entire region of the universe you call home. The Earth rotates. The Earth orbits the Sun orbits the galactic center. The Milky Way flows toward the Great Attractor. Every scale of motion is nested inside a larger one, and at the largest scale we can measure, we are all moving together, 100,000 galaxies synchronized in their fall toward a gravitational center we cannot see with visible light. But Laniakea is not a permanent address, it is not gravitationally bound. Unlike a galaxy which holds itself together against the expansion of the universe, or a galaxy cluster which remains intact across billions of years, Laniakea is too large and too diffuse to resist the pull of dark energy. The unknown force that causes the universe's expansion to accelerate confirmed in 1998 when two independent teams observing distant supernova found that the expansion was speeding up rather than slowing down, a discovery that earned Adam Rees, Saul Perlmutter, and Brian Schmidt the Nobel Prize in Physics in 2011. Dark energy constitutes roughly 70% of the total energy content of the universe, a force with no name we can explain, and it pushes harder than gravity can pull. At cosmological scales, the universe expands faster than gravity can gather. The Great Attractor is already receding from us. The expansion of space means we will never physically reach it, even as we are pulled toward it. Gravity pulls. Dark energy pushes harder. The destination recedes. We will never arrive. This is not a tragedy. It is simply the way the universe is structured at the largest scales. Motion and distance and time are woven together in ways that defy the intuitions we carry from our small corner of existence. We are moving towards something we can never touch, inside a structure that will eventually dissolve, carried by a current that has no final shore. The flow is real, the motion measurable, the direction clear, but the arrival is forbidden by the geometry of space-time itself. And yet the current is real, the motion is real, the structure is real, even if it is temporary. For now, across this moment in cosmic time, 100,000 galaxies flow together through the same watershed, bound not by gravity alone, but by the shared direction of their motion. And the Milky Way is one of them. Not at the center, not leading the flow, a participant among millions, carried along with everything else in this region of space, part of a pattern so large that it took until 2014 to see it whole. You are not adrift, you are not isolated. You are part of the largest current of matter that exists in our observable universe, a passenger inside a flow that began long before the first stars formed, and will continue long after the last light fades. The map that was completed in 2014 gave Laniakea its name, Immense Heaven, chosen to honor the Polynesian navigators who crossed the Pacific by reading the stars. That map is the first true picture of where we are. Not a galaxy, not a cluster, a supercluster defined by motion, by the flow of everything within it toward the same gravitational center, traced not by looking at where galaxies are, but by measuring how they move, the way water reveals the shape of a landscape by the direction it flows. We are in the outskirts. We are near the edge of a structure so large it took us until 2014 to know we were inside it, so diffuse that it will not survive the expansion of the universe, so vast that 5,000 Milky Ways could fit across its width. The Great Attractor lies far ahead, and beyond it Shapley waits, pulling the Great Attractor just as the Great Attractor pulls us, and beyond Shapley the map fades into uncertainty, into regions we have not yet traced. The motion is layered, the structure is nested, and at every scale we are carried. This is what it means to know where we are. Not a position on a map with fixed coordinates, but a place inside a flow, a current that moves through time as much as through space. The Milky Way is not the center. Laniakea is not the center. Even Shapley may not be the final center. The universe continues beyond every edge we have mapped, and we do not yet have the instruments to read it. But tonight you know this much. You are inside Laniakea. You are part of the flow. You are being carried, right now, across a distance no human mind can fully hold, toward a destination that recedes as you approach it, inside a structure that will one day dissolve but for now, across this brief span of cosmic time, holds together 100,000 galaxies, synchronized in their motion, falling together toward the same unseen center, and you are among them. You do not need to understand it completely. You only need to rest inside it. The motion continues, whether you wake or sleep. The current carries you either way. Every map has an edge. This one took us until September of 2014 to draw, and the moment we finished it, we discovered it was incomplete. Laniakea stretches 500 million light-years from one boundary to the other. 100,000 galaxies flow inward toward the same gravitational center, tracing invisible currents through the void. The Milky Way sits near the outer edge of this structure, moving at 630 kilometers every second toward a focal point we named decades before we could see it. The Great Attractor lies almost directly behind the plane of our own galaxy, hidden by dust and starlight, a destination obscured by the very motion it commands. For years, the Zone of Avoidance blocked our view. Nearly a fifth of the extragalactic sky remained invisible at optical wavelengths, the Milky Way's own gas and dust forming a curtain we could not draw back. Radio telescopes and infrared instruments slowly filled in the blank regions, wavelength by wavelength, until the Norma cluster emerged from behind the veil. A diffuse concentration of matter 400 million light-years across, not a black hole, not a singularity, but a place where gravity gathers and holds. We thought we had found the answer. The Seven Samurai had named it in the late 1980s, tracing the peculiar velocities of 400 elliptical galaxies, mapping the infall, identifying the direction. The cosmic microwave background showed us we were moving. The dipole asymmetry, warmer in one direction, cooler in the opposite, revealed that the local group was flowing at more than 600 kilometers per second towards something specific. The Great Attractor seemed to account for it all. Then, in 2005, an X-ray survey revised the mass downward by nearly 90%. The Great Attractor was real, but it was not the whole story. Behind it, 650 million light-years away in the constellation Centaurus, the Shapley Supercluster waited, one of the largest gravitationally interacting structures in the observable universe, pulling not only the Milky Way but the Great Attractor itself. More than half of our motion may be driven not by the focal point we named, but by the vastly larger concentration of mass beyond it. The pull does not stop. Gravity does not recognize borders. Some astronomers now believe that Shapley may be the gravitational anchor of everything in our corner of the cosmos, the center toward which Laniakea and several neighboring superclusters are all flowing. Others are less certain. The map keeps expanding, and every time we extend its boundaries, we find that the structure we thought we understood is nested inside something larger still. Laniakea is not a permanent address. It is defined by motion, not by walls. Brent Tully and his colleagues at the University of Hawaii traced the watershed, the volume of space where all galaxies flow inward toward the same center, and they gave it a name from the Hawaiian language. Laniakea, immense heaven, a name chosen to honor the Polynesian navigators who crossed the Pacific by reading the stars, who understood that to know where you are, you must first understand the current. We are in the outskirts, passengers at the edge of a structure so large it took us until 2014 to know we were inside it. The Milky Way is 100,000 light-years across. Laniakea is 5,000 Milky Ways wide. Within it, 100,000 galaxies are all flowing in the same direction, their motion synchronized across distances no human mind can fully hold. And yet Laniakea itself is not bound. It is too large, too diffuse to hold itself together against the expansion of the universe. Dark energy, the force with no name we can explain, constitutes roughly 70% of the total energy content of the cosmos. In 1998, two independent teams observing distant supernovae found that the universe's expansion was not slowing down but speeding up. Adam Rees, Saul Perlmutter and Brian Schmidt shared the Nobel Prize in Physics in 2011 for confirming what no theory had predicted. The universe is accelerating away from itself. At cosmological scales, expansion wins. Gravity pulls. Dark energy pushes harder. We are moving toward the Great Attractor at 630 kilometers every second. The Great Attractor is already receding from us. The expansion of space means we will never physically reach it, even as we are pulled toward it. The destination recedes, we will never arrive. This is not a failure. This is the condition of the cosmos. We are not at the center of anything. The Milky Way sits in the outer regions of Laniakea, which flows toward the Great Attractor, which is itself pulled toward Shapley. We are carried across 500 million light-years of structure, in a current that has been flowing since before the Earth existed, toward a place we will never touch. The map has an edge. Beyond the Great Attractor, beyond Shapley, the universe continues, and we do not yet have the instruments to read it. The dark holds no record of arrival. The map is the journey. But tonight you know where you are. You are inside Laniakea. You are part of the flow. You are being carried, right now, across a distance no human mind can fully hold, toward a gravitational center hidden behind the plane of your own galaxy, moving at 630 kilometers every second through a structure that will not survive the expansion of space. You do not need to understand it, you only need to rest inside it. The current does not ask for your consent, it simply carries you, and in this moment that is enough. Right now, as you lie still, you are moving. The bed beneath you is fixed to a floor that rotates with the Earth at more than 1,000 kilometers an hour. The Earth orbits the Sun at 30 kilometers every second. The Sun carries the entire solar system around the center of the Milky Way at 220 kilometers per second. And the Milky Way itself, along with every galaxy in our local neighborhood, is flowing through space at 630 kilometers per second towards something we cannot see. This is not the universe expanding, this is us moving towards something specific. Motion inside motion inside motion. And at the largest scale, the motion has a direction. Something is pulling us. For decades, we did not know what it was. We only knew that we were moving. In the 1970s, astronomers measured the faint light left over from the Big Bang, the cosmic microwave background that fills the entire sky. It should have been perfectly uniform in all directions, the same temperature no matter where they looked. But it was not. In one direction, the light was slightly warmer. In the opposite direction, slightly cooler. The asymmetry was small, but it was real, and it had only one explanation. We were moving towards something. The warmth was the light compressed by our motion. The coolness, the light stretched behind us. The entire local group of galaxies was drifting at more than 600 kilometers every second, and no one knew why. In the late 1980s, a group of 7 astronomers set out to map the motion. They called themselves the 7 Samurai. Alan Dressler, Sandra Faber, David Burstein, Roger Davies, Donald Lyndon Bell, Roberto Telovich, Gary Wegner. They measured the distances and velocities of hundreds of elliptical galaxies, tracing the flow of matter across hundreds of millions of light-years. What they found was not random drift. It was coherent infall. Galaxies were being pulled, all of them, toward a single region of sky. The 7 Samurai named a destination. They could not yet see it. They called it the Great Attractor. The name sounds like science fiction. It sounds like a threat, a cosmic predator waiting in the dark. But the Great Attractor is not a black hole. It is not a singularity. It is not a thing at all. It is a place. A gravitational focal point, a diffuse concentration of matter roughly 400 million light-years in size, located between 150 and 250 million light-years from the Milky Way, in the direction of the constellations Norma and Triangulum Australe. Millions of galaxies are flowing toward it, including our own, not because it is pulling them with some exotic force, but because mass bends space, and where there is enough mass, everything nearby begins to fall. The Great Attractor pulls the Milky Way. It pulls the local group. It pulls the Virgo supercluster. It pulls the Hydra Centaurus supercluster beyond it. Millions of galaxies, all flowing in the same direction. Some at 600 kilometers per second, others at thousands. A current so large it took decades to recognize that we were inside it. And for decades, We could not see what we were moving toward. The Great Attractor lies almost directly behind the plane of the Milky Way, hidden in a region astronomers call the Zone of Avoidance. Our own galaxy was hiding the answer from us. The gas and dust and stars of the Milky Way's disk obscure nearly a fifth of the extragalactic sky at visible wavelengths. Everywhere the Great Attractor should have been visible, there was only the foreground glow of our own galaxy, a curtain of light we could not see through. For years, the Great Attractor was a name without an image, a destination inferred from motion but invisible to our instruments. But radio waves pass through dust. Infrared light passes through dust. As X-ray and infrared astronomy became more powerful in the 1990s and 2000s, astronomers could finally begin mapping what lay behind the veil. Slowly, the map was filled in, one wavelength at a time. X-ray surveys revealed the Norma Cluster, a massive concentration of galaxies at the center of the Great Attractor region. The focal point had a face. And then, when we finally looked closely, we found that the Great Attractor was not the whole answer. Behind it, something far larger was waiting. In 2005, an X-ray survey revised the mass of the Great Attractor downward to roughly 1/10 of the original estimate. The pull was real, but the mass was not enough to explain it. The Milky Way was being pulled towards something beyond it, something so massive that the Great Attractor itself was only a waypoint. The destination had a destination. But to understand what that meant, astronomers first had to map the structure we belonged to. In September 2014, astronomer R. Brent Tully of the University of Hawaii and his colleagues published a landmark paper in the journal Nature. They had traced the peculiar velocities of galaxies across hundreds of millions of light-years, mapping not where galaxies are, but where they are going. They were looking for the watershed, the volume of space where all galaxies flow inward toward the same gravitational center. What they found was larger than anyone had imagined. They named it Laniakea, immense heaven, a name chosen to honor the Polynesian navigators who crossed the Pacific by reading the stars. Laniakea is approximately 500 million light-years across. It contains roughly 100,000 large galaxies, with a total mass of 100 quadrillion suns. It is not defined by boundaries, it is defined by motion. Think of it like a watershed on Earth. Rain on one side of a mountain flows into one river. Rain on the other side flows into another. Laniakea is our cosmic watershed. Everything in it flows toward the same center. The Great Attractor is that center. And we are in the outskirts. Passengers at the edge of a structure so large it took us until 2014 to know we were inside it. The Milky Way sits near the outer rim of Laniakea, drifting inward at 630 kilometers per second, carried by a current that has been flowing since before the Earth existed. Across 500 million light-years, 100,000 galaxies are all moving in the same direction. We are not wandering. We are part of the flow. But the flow does not stop at the Great Attractor. 650 million light-years from the Milky Way, in the constellation Centaurus, lies the Shapley Supercluster. It is one of the largest gravitationally interacting structures in the observable universe. And the Great Attractor is moving toward it. The pull does not stop. It continues beyond the focal point we named, beyond the center of Laniakea, towards something larger still. Studies suggest that more than half of our motion may be driven not by the Great Attractor, but by Shapley. The Great Attractor is not the final destination. The Great Attractor is itself being pulled. Some astronomers now believe that Shapley may be the gravitational anchor of everything in our corner of the cosmos. That Laniakea and several other nearby superclusters are all flowing toward it. Others are less certain. the map keeps expanding. But there is a problem, a paradox woven into the structure of the universe itself. Laniakea is not gravitationally bound. It is too large, too diffuse to hold itself together against the expansion of space. Unlike galaxies, unlike galaxy clusters, Laniakea is a temporary structure. It is a current, not a harbor, and the universe is expanding faster every moment. In 1998, two independent teams observing distant supernova found that the expansion of the universe was not slowing. It was accelerating. The discovery earned Adam Rees, Saul Perlmutter, and Brian Schmidt the Nobel Prize in Physics in 2011. They had found evidence of a force with no name we can explain, a force that constitutes roughly 70% of the total energy content of the universe. We call it dark energy, but the name is only a placeholder for our ignorance. We know what it does. It pushes space apart faster and faster, and at the largest scales it pushes harder than gravity can pull. The Great Attractor is already receding from us. The expansion of space means we will never physically reach it, even as we are pulled toward it. We are moving toward it. It is moving away from us. Gravity pulls. Dark energy pushes harder. The destination recedes. We will never arrive. This is the verdict. We are part of the largest current of matter that exists in our observable universe, flowing across 500 million light-years toward a gravitational center we will never reach, toward a destination that is itself being pulled toward something larger, and the expansion of space ensures that the journey has no ending. We are passengers in a structure that is dissolving even as we cross it. Laniakea is not a permanent address, it is a motion, a direction, a belonging that exists only in the present tense. And perhaps that is enough. We are not at the center of anything. The Milky Way sits in the outer regions of Laniakea, which flows toward the Great Attractor, which is itself pulled toward Shapley. We are carried. The Milky Way is 100,000 light-years across. Laniakea is 5,000 Milky Ways wide. Within it, 100,000 galaxies flow in the same direction, and we are one small galaxy near the edge, and on one arm of that galaxy, a single star, and around that star, a small blue world where you lie in the dark, moving at 630 kilometers every second, towards something you will never see. You do not need to understand it, you only need to know that you are part of it, that the motion is real, that the current has been carrying you since before you were born. You are not separate from the flow, you are inside it, you belong to it. Every map has an edge. Beyond the Great Attractor, beyond Shapley, the universe continues, and we do not yet have the instruments to read it, but tonight you know where you are inside Laniakea. You are part of the flow. You are being carried, right now, across a distance no human mind can fully hold, toward a destination that recedes, in a structure that will not last, and that is the nature of all journeys. The dark holds no record of arrival, the map is the motion, and you are here, drifting, among galaxies. You came this far. You traced the current that carries you, the pull that began before your species existed, the flow that will continue long after every star in the Milky Way has burned out. You followed the map to its edge, where gravity and dark energy race, where the destination recedes as you approach. If you fell asleep somewhere along the way, that's good. If you stayed, that's good too. Wherever you are tonight, the dark will still be here. So will I. Tomorrow night, if you want, we'll go somewhere else. Same time, same voice. A different corner of the cosmos that doesn't care whether you understand it, only that you're willing to listen. Rest now. Laniakea is still carrying you. You don't have to do anything at all.